Hello students, welcome to lecture 4 of alcohols, phenols, ethers. Here still we are learning the preparation of the alcohol. Now we are going to learn a preparation of the alcohol from a Grignard reagent. So preparation of alcohol only. The topic is preparation of alcohol. Preparation of alcohol. This is the main topic and by by reaction with with by reaction of what? By reaction of carbonyl compound. Carbonyl compound. Now you know what is the meaning of carbonyl compound. Carbonyl compound means it is either aldehyde, or ketone, right? With Grignard reagent. With Grignard reagent. Now the thing about this is that by this method we can prepare a tertiary alcohol also. So first we'll learn what is Grignard reagent. Grignard reagent is what? It is general formula is this R mg x means R is also variable over here. R is what? R is a alkyl group. R is a alkyl group, right? And X is what? X is halide, halogen like fluorine, chlorine, bromine, iodine. So examples of the Grignard reagent. First, we have to know what is Grignard reagent, then we'll do the reaction. Examples is this CH3 MgCl, or it could be CH3 CH2 MgCl. Instead of Cl, it could be a Br also. I can write this CH3 CH2 CH2 MgBr. It could be this also, a aromatic ring. R could be aromatic ring also, MgCl. All these are the examples of the Grignard reagent. Now, what we'll do the reactions of the Grignard reagent. See, the thing is, I'll give you the trick. What is very important, what I feel over here is knowing the trick and a kind of small mechanism will do. First, I will write this. So this is the thing here. Let's say this is your carbonyl compound. This is your carbonyl compound. Means this is our aldehyde. It can be a aldehyde or it could be a ketone. Now, how it will be aldehyde or a ketone? Like if this is R and this is H, it is a aldehyde, right? Or both are R, then it is ketone, or both are H, then it is aldehyde, right? So let's not write anything over here. Let's not write anything over here because these are the two bonds in throughout the reaction remains intact. I am reacting this with a Grignard reagent R mgx. Understand? A electron rich. This is a pi bond which is a electron rich. It is going to attack the electron deficient. Who is electron deficient? In the Grignard reagent, this is negative, this is positive, and this is also negative. So it is going to attack over here, and this is going to attack this carbon, right? And next, what you get, like this reaction happens in the presence of dry ether. This is a solvent. So this is what happens. OMgx, what you get over here, and this is the R from the Grignard reagent. Further, if you do the hydrolysis means this way, H. This represents hydrolysis. Hydrolysis means breaking of the bonds using water. I want to break this bond. No? So further, this is the compound. This will change to OH plus MgOH is the byproduct over here. Now, students, you tell me what kind of alcohol is this? Primary, secondary, or tertiary? At this point, we are not able to judge because I did not fix this whether this is aldehyde or a ketone. So, what I'll do, these steps you have to remember. Mechanism is this simple, and we'll do this. We'll do with the aldehydes and ketone. If you are given a aldehyde, let's say um, CH3 CH2 C HO. This is the aldehyde. What is the name of this aldehyde? Name of this aldehyde is propanol. Propanol. How you will solve this? With a Grignard reagent, RMgX. We'll take this to be a methyl magnesium bromide. Let's take this as a Grignard reagent. How you are going to solve this and what would be a product over here? The simple thing is that first convert this, means write it in this format, write it in this format, right? Means I am writing it in this format means what? I am writing this CH3, CH2, C, and this is what? H, and this is double bond O. Now, these two bonds throughout the reaction you are keeping intact, right? No, the first thing I have written it this way. You have to write it this way, and I am reacting this with a Grignard reagent, that is methyl magnesium bromide, in the presence of what? It is a dry ether. In the presence of dry ether, what do you get? CH3, CH2. This is H as it is. This changes to OMG Br. And this is that CH3 from a Grignard reagent. This is that CH3 from a Grignard reagent. Next, what you will do? Next, you are going to do the hydrolysis. You are going to do the hydrolysis. H plus and water. Next, you are going to do the hydrolysis. So what you get over here is this CH3, CH2, hydrogen, CH3 and OH plus Mg, OH, Br as the byproduct. So what is the alcohol we are getting? What is the name of this alcohol? Name of this alcohol, here there is no space, but I'll write here what is the name of this alcohol. It is, this alcohol could be written in this format, like those who are very beginner in learning the IUPAC nomenclature. It is this way. CH3 I'll write. This is next CH2, and then it is CH, and then CH3. If I write it in same format, means this is my uh, carbon 1, this is carbon 2, this is 3, and this is 4. So this is 1, this is 2, this is 3, and this is 4. So here I'll mark this as what? Here it is OH. So what is the name of this alcohol? You know this. It is butan 2-ol. The name of this alcohol, what I am getting is a butan 2-ol, right? And it is a secondary alcohol. Next could be this way. Next reaction could be this way. Um, I'll see this using a Grignard reagent. Question may be this way: using um, Grignard reagent or using ethyl, or we'll do this way. If you are given a compound, if you are given a compound this way, CH3, CH2, C double bond O, CH3. This is what? It is 5 carbon, no? And it is pentan. What position is the double functional group? This is 1, this is 2, this is 3, 4, and 5. Pentan 2-ONE. This is the ketone. If you react this with a Grignard reagent, let's say methyl magnesium bromide, what would be the product? The reaction is simple. First thing is trick is that you need to convert it in this. Convert means just real. Double bond O you are writing over here. This is CH3. What is this? This whole part could be written as a C2 C3H7 also. I'll write this C3H7. Instead of writing a whole chain, I'm writing C3H7. Not necessary. You can write it in an open form also and react this with a Grignard reagent, methyl magnesium bromide. So what would be a product in the presence of dry ether? Dry ether, it is this C3H7. This is CH3. This is OMgX or OMgBr. And this is what? This is CH3 from the Grignard region. Further, if you do the hydrolysis, that is H plus water. What is this? This process is called as hydrolysis. Means what you get, C3H7, CH3, CH3, and OH plus MgOH Br. What is the name of this compound? How to write the name of this compound? If you open up this, then it is this, no? CH3, CH2, CH2. This is the carbon. Here it is methyl. Here also it is methyl. And this is the OH. How to name this? You will do this way. This is 1, this is 2, this is 3, this is 4, this is 5. This is how you do the numbering, right? So this is the longest chain and this is the substituent and this is the functional group. So always we write a prefix first, that is 2-methyl. What is word root? Pent. All are carbon carbon single bond, so A and E, and replace last E with a functional group, that is 2OL. So this is the name of the product and this is the product. So what is this? It is a tertiary alcohol. Now what would be the, if I want to prepare a primary alcohol, what would be the thing I have to take? Like aldehyde and ketone, but if I take a aldehyde I get a secondary alcohol, and if I take a ketone, I get a tertiary alcohol. But if I do this formaldehyde, if I react, formaldehyde formula is what? HCHO plus, we'll take a Grignard reagent, CH3 MgBr. What we are doing? Final product, we want a preparation of primary alcohol, right? So this is HC, here also H, this is double bond O, and this is methyl magnesium bromide. In the presence of dry ether, this is hydrogen, this is hydrogen, this is O, MgBr, and this is CH3. Further, hydrolysis of water will give you, sorry, hydrolysis by water, not of water. This is the compound which you are going to get. What is this? If I write it, this is the first carbon. There are just two carbons, no? I can write it in this format. CH3, CH2OH. What is this? Ethanol. Byproduct is MgOH Br. So this is the methods for the preparation of the alcohol. So in summary, right? What is the summary of this? Summary of the Grignard reagent reaction. If you choose a aldehyde, if you choose a aldehyde, or if you just choose a formaldehyde, if you choose this, which is known as methanol also, this is also known as methanol, or it is also called as a formaldehyde. If you choose this formaldehyde, the what would be a product you are going to get? You are going to get a primary alcohol. If you choose this to be a aldehyde, the product what you get is a secondary alcohol. And if you choose this to be a ketone, if you choose this to be a ketone, then what you get is a tertiary alcohol. Whole reaction is very simple. This is a whole summary of the reaction of the carbonyl compound with a Grignard reagent. Next, we'll learn the preparation of the alcohols by hydrolysis of ester. So I'll write the name over here, by hydrolysis of ester. So we are doing the preparation of the alcohol. Still, we are preparing the alcohol, preparation of alcohol. So what is the meaning of hydrolysis? Hydrolysis is breaking of bonds using a water. You take a carbonyl, C double bond, sorry, not carbonyl, you take a ester, this is a R dash. and R. This both R and R, R dash and R may be same or may not be same. Hydrolysis means what? This OH minus will attack on the electron deficient carbon. Yes, this is the electron deficient carbon because it is connected to two electronegative element. Electronegative means what? Tendency to attract a share pair of electron towards itself. So that's why this is partially positive carbon. So what will happen? This bond will break this way. Then it will back bond, and this will go with it. Or what I can say is that I can show it this way. This is a lone pair. No, it will also interact with a H plus part of the water. Right? It is going to do this way, and this is the bond which is going to break. So what you get over here is two things. One COOH, and other is R dash OH. R dash OH. This is the alcohol. Now, this is the carboxylic acid. Like, this is the thing which is happening at the end, right? Now, but the reaction which is given in the NCRT, it is this way. Like here, what you get, you are getting a carboxylic acid after hydrolysis. This is carboxylic acid, and this is alcohol. So, reaction which is given in the NCRT is this way: RCOO R dash. We are putting NaOH, sodium hydroxide, in aqueous medium. Means this hydrolysis is done in a basic medium. So here the product what they have written is this RCO O minus and a Na plus, sodium salt of a carboxylic acid, and you are getting R dash OH. Now how we are getting this? See, in the presence of the base, what will be the thing? Once you get this product, it will react with it. Base and a salt, base and a acid, when they react, you get a salt of it. So this is, always remember that NaOH which is there, it will react with a carboxylic acid form, RCOOH, right? This is a base, this is a base, and this is acid, right? So what will happen? Acid and base, when they react, it gives you a salt, right? That is what the salt is. So this is the product what you are getting over here, and this is the whole reaction. The whole reaction what you get. So don't get confused why it is a salt. This is sodium salt of sodium salt of carboxylic acid. This is alcohol. More example of this we can write in this manner. If we have a ester of this kind, okay, we'll write this CH3 C double bond O C2H5. And if you are doing the hydrolysis NaOH aqueous medium, what you do is hydrolysis. What you get is CH3 CO O minus and Na, and other alcohol what you get is CH3 CH2 C2H5, no, and this is OH. So you are going to get a ethanol in this case. So this is the simple trick to remember this reaction.